Good morning, students. Welcome to the online teaching session of Academic World School Bemetra. This is the session for Science Physics for class 10th. Today's chapter we are dealing is effects of electricity. The topics which I am going to teach you today is the mechanism of the flow of current through any conductor, Ohm's law and its verification. And lastly, we will be studying about the resistance. I request you all students to open your notebooks and note down whatever I am going to teach and write on the board. So, are you ready, students? With me. The first topic is the flow of current. In our previous session, we have seen what is current. Current is the flow of charge through any conductor. Any conductor or a metallic conductor is a piece of a metal that is made up of innumerous number of atoms in it. Those atoms, they have got free electrons in them. Now why do they flow? The flow is affected by the battery. You know, your Walkmans, your tape recorder, your mobiles, they do not work properly if you take out the battery. So battery is the main thing that provides current. In your home there is no battery, there is electricity plug socket. So plug socket is another thing that provides the potential difference. So here is the battery, or you can replace it with plug socket in case, and this current in the conductor. Now this is, I have drawn here a cross section of a conductor. The conductor will have many atoms in them. For example, you are using a copper wire as a conductor in all your home. So the copper wire will have number of copper atoms, and all these copper atoms will have the free electrons in their outermost shell. When you connect the battery and plug the key in, now there is a difference. What happens? The positive terminal applies one positive potential at the one end A of the conductor. Because of this positive, you all know the positive charges attract the negative. Electrons, these dots I have represented. So electrons are attracted towards the positive terminal, and there is a vacancy created. Now this vacancy will be accomplished by another electron from the neighboring atom. So the vacancy will now switch to this. In this way, the vacancy will go on switching from the side A to side B, and electrons will keep on drifting from B to A. Electrons go from B to A. The negative charge is going from B to A. So direction of electron B to A. But the positive charge will go from A to B. Electron is negatively charged. When electron moves from B to A, we can say a positive charge is going from A to B. This is why the direction of current is taken as direction of current is taken A to B. Whereas the direction of electron is B to A. So you can say electrons and conventional current are in opposite direction. So the mechanism of flow of current is like this, that when you connect a battery, the battery will apply a potential difference at the ends, and therefore the electrons will switch in B to A, and in this way the current will flow in direction A to B. I hope it is clear how the current is formed in any conductor. Next we move to the thing that why the amount of current will be different in different conductor. For this there is a famous law popularly known as Ohm's law. So before we go and read the Ohm's law, we must know how to make the circuit. You are using fan, bulb, different kinds of cells and batteries. How to represent them? If I ask you, how have you made a torch? How have you made a circuit? So will you draw all that? If you are a good in drawing, you may draw. But there are who cannot draw all these things perfectly. For that easiness, we are using symbols. What are the popular and commonly accepted symbols? Components and their symbols. A switch is shown by the symbol like this. This is open switch, and when you close it, it is like this. Or it may also be like this, an open switch, and closed switch. You have inserted the key. This dot represents the key. A bulb is shown by the symbol like this. Resistance is drawn like this. These are the scientifically accepted symbols which we are using in our circuit diagrams. Ammeter is shown like this. You make a circle and write a A. Then voltmeter. Why I am teaching you all this? Because we will be using these symbols throughout the lesson. A capacitor. You will read in higher class about this. This is a rheostat. Variable resistance. It is so these are some of the used symbols that we will use in our circuit. Write the definition of circuit. A path made of a conductor through through which electric current can flow. This is called a circuit, and circuit diagram. There is a difference in circuit and circuit diagram. Circuit is a physical thing. When you connect a bulb, a cell with connecting wires, you can call it a circuit, you can touch it. But when the same thing is drawn as a diagram on a paper, that diagram is called circuit diagram. Circuit diagram is easy to share the idea through picture. So, as I told you, the current passing through any conductor is because of the cell applied across the ends of the conductor. Now let us see how the current and this one potential difference, they are linked. Ohm's law says that if the physical parameters remain constant, physical parameters such as temperature, pressure, humidity, etc., if these are not changing, then the potential difference and current, they are directly proportional to each other. Please write the definition of Ohm's law. It says that, it states that current flowing through a conductor is directly proportional to the potential difference applied across the two ends of a conductor, provided the physical parameters remain constant. So when we explain it, it will be current is proportional to potential difference, or I can write in the reverse way, V is proportional to I. Now this is proportional sign. I can remove the proportional sign by introducing one constant R. I have introduced a constant. This R is resistance. And to know more about resistance, R is equal to V upon I. So what is resistance? Students, resistance is ratio of voltage and current. Resistance is ratio of voltage and current. What we can understand this resistance as the hindrance in the path of the free flow of any charge or current through any conducting wire. Any conducting wire, when current flows through it, then the material, due to its own property, it creates some hindrance, and that hindrance is known as resistance, and it is given by the ratio of voltage and current. Let's see what can be the unit. The unit of resistance is on the name of the great scientist, ohm. So 1 ohm is 1 volt per ampere. One ohm is 1 volt per ampere, or you can write the definition of 1 ohm. Define 1 ohm. What is 1 ohm? 1 ohm is when 1 volt potential difference is applied across the ends of a conductor through which 1 ampere current is flowing, then the resistance of that conductor is said to be 1 ohm. 1 ohm. This is the Greek alphabet omega, which is used as the symbol for ohm. 1 ohm is 1 volt per ampere. There are bigger units of this ohm, like as 1 kilo ohm. When there are 1000 ohms, we can call it as 1 kilo ohm. Similarly, further bigger unit is 1 mega ohm, which is equal to 1000 kilo ohms, or you can say 10 to the power 6 ohms. 1 ohm, 1 kilo ohm, 1 mega ohm, they are the various units of resistance. You all must be wondering, where do we use these resistances? So let me tell you, the regulators of the fan in your home, that is an example of a resistance. When you use it at highest power, the fan is moving fastest. At that time, you are using the least resistance or no resistance. But when you decrease it, try to decrease the speed of the fan, then you are increasing some amount of resistance of that regulator. In that way, you decrease the current which flows in the coil of fan, and in that way the fan decreases its speed. So I hope everybody now knows what is a resistance. Next time when you use the regulator, you will easily remember what is a resistance. It's an example of a variable resistance where you are changing the values of resistance, and we are using the adapted this one. So Ohm's law says when potential difference is applied across the ends of the conductor, the current is directly proportional to it. Can it be verified? Yes, we can very well verify the Ohm's law, and today I have brought the apparatus for you to verify this Ohm's law. Let us do it right here in the online class. My dear students, what I am having with me now, this is, my dear students, this is the apparatus for Ohm's law. So all of you please write down the aim of this experiment that we are, the activity experiment which we are going to do it right now. Aim of the experiment to verify the Ohm's law. And for this, what do you need? That is apparatus. You need a voltmeter, an ammeter, a resistance wire, rheostat, some connecting wires, switch, now how do we connect all these apparatus? The connection is simple. We will be using the symbols of the component that we have studied. We will first connect one resistance and a voltmeter, both of them in parallel. Then with this we will connect one switch and a rheostat. The rheostat is connected to a battery, and here is one ammeter. Students, look at the diagram and draw it neatly in your notebook. This is called the circuit diagram for verification of the Ohm's law. Let me label it for you. This is the resistance, this is voltmeter, ammeter, here is a battery, this is rheostat, and this is your key. So according to Ohm's law, the theory says current is proportional to potential. Let us see it experimentally. Now this is the Ohm's law circuit board. I have a ready-made set for this, and here I have, this is ammeter, this is a voltmeter, and these are the okay. Now when I move the knob, you can see as the current increases, in the same way the voltmeter also increases. All of you can see here, where this is ammeter and this is voltmeter. Please look carefully at the needles of these. When I move the regulator, the pointers of both of them are simultaneously growing. This proves that when you increase the potential, the current also rises. That's what is Ohm's law. So let's do the experiment and complete it. So I will be taking the readings and noting down the values for you. Draw one table. This is 50 milliampere and here the voltmeter reading is 0.1. Now when I increase it to 100 milliampere, it is 0.2. Next I increase it to 150. The reading of the voltmeter is 0.3. So this is how we will obtain one table between the voltmeter and the ammeter. Now the next thing is we have to plot a graph with these values, and also we can calculate the resistance in each case. How to calculate the resistance? As you all know, resistance is ratio of V and I. So let's see what is the value of V here. 0.1 and 0.05. For first set of readings, the voltmeter reading is 0.1 and the ammeter reading is 0.05. So multiplying by 100 upon 5, this is 20 ohms. Two ohms. So the resistance is 2 ohms. Let's solve it for another set of reading. Let's this time take the last reading, 0.4 and 0.2. Resistance at the fourth set of reading is V upon I, that is 0.4 divided by 0.2, again multiplied by 10. So it is 4 upon 2 and that is 2 ohms. So in both the cases we find that the value of R remains constant, that is 2 ohms only. Our next job is to draw the graph for these two values. For that, all of you take one graph paper and on the x-axis mark the points of voltage 0.1, 0.2, 0.3, 0.4, and on the y-axis you take the readings of current, that is 0.05, 0.1, 0.15 and 0.2. Now if you join the two readings coordinate, you will get 1 point for set 1 reading and this is for set 2 reading set 3 and set 4. If you join all these lines, all these points, they all appear to be on a straight line. Straight line between the two values V and I concludes that the voltage is directly proportional to current. Voltage is proportional to current, and that is what is the Ohm's law. Hence, we have verified the Ohm's law. So, how to verify the Ohm's law? Take a voltmeter, ammeter, resistor, rheostat and connect them in a circuit board like this and take readings. Draw the graph. If the graph comes a straight line, hence you have verified that voltage and current are directly proportional to each other. So we have seen what is 1 ohm and what are the units of resistance, and we have verified the Ohm's law. There are few homeworks for you that will be uploaded in the ERP. Go through the ERP and do the homework in your assignment work. Be ready for the next lecture, which will be on the factors for which the resistance depends. Thank you. Wish you a happy learning day.